All right, well, thank you for inviting me to share with you today. I hope that some of the experiences I've learned and what I can share with you today is going to be beneficial to you. I am not the expert. I've got a bit of experience to share, and I hope you find it useful. Playout and media workflows in the cloud. First of all, what's the cloud? Everyone uses the term, but the reality is the cloud is just somebody else's computer hardware in someone else's building. So you're using compute power that isn't maintained by you, and you don't have to worry about. But what makes a broadcast playout chain? There's quite a few elements that are involved in that. There's network management and monitoring, automation and asset management, and then you have to have operational interfaces. All of this on top of file-based playout workflows, cloud infrastructure, virtualization, and monitoring solutions, and finally, compression and media transport solutions. In my world, this is what the operators end up seeing. They see network management on the left, they see their automation playlist in the center, and on the right-hand side, if they need to be involved to manually manipulate graphics or the schedule for live events or unscheduled things, we provide them touch surfaces that they can use to control playout. So I want to talk mostly about file-based playout solutions. It's probably the thing that's most interesting to people in this room. I suspect most of you are broadcasters, not producers. So I'll spend a little more time on that and get into the MAM workflows following that. How many of you have drawings like this? Still in your plant where you have discrete devices doing discrete tasks. You've got video servers, you've got audio mixers, you've got master control switchers, keyers, SCSI embedders, GPI inserters, all that kind of thing going on in discrete boxes that are all nicely connected together, and if you follow all the dotted lines, somewhere a program comes out. With the advent of computer technology getting faster and cheaper, Moore's Law says that it doubles in speed every 2 years. We can now do all of these things inside computer-based systems. And that was the start of what's allowed us now to move towards virtualization. We can move that whole chain into a computer. So that computer software still has the same functionality. It's got the video playout servers, it's got the live source switching. We de-embed the VANC so that we can do the VANC processing and inserting. Audio de-embedding so that we can do audio mixing for voiceovers and reshuffling the audio to put languages in the right position, and SAP and all kinds of nice things. Video mixing so that you can transition properly between program events, graphics layers. Nice thing about computers, you can add graphics layers just by adding software. In our systems, we generally do 6 to 10 different graphics layers. And then, all that has to get output again, so the audio gets re-embedded, the VANC gets re-embedded, and then the output comes out either SDI or IP. Here's some of the things that we have capabilities to do inside our software-based playout systems. You can see we've got up-down conversion, down mix, up mix, IntelliGain for ComAc compliance. All that kind of thing is capable of being done inside computer systems. So this moves us from specific hardware that has single functions onto generic hardware, which gives a lot of advantages. We can moving away from hardware to software lets us move into the cloud. We can run software on consistent platforms. We don't have to buy this card from Joe and this card from Chuck, although Chuck loves to sell cards. But we can also change what those computers do with simple upgrades. It also gives us scalability. We can add more of the same and just add more software to grow the number of channels we have. And it's easier to maintain. Computers can be learned. You don't have to know specifically the circuitry design for the embedder and for the keyer. You can just work with computer systems and software. But to completely go virtualized, you have to give up SDI I/O. And I know for some people that's going to be a thing that hurts, but the reality is computers, you can't virtualize without getting rid of hardware cards that are function specific. So we have to lose the SDI I/O and move to TCP/IP based streams. We thought we could get rid of GPUs, but as we started doing all the processes we needed to do to accomplish that big block diagram of functions, we realized that the GPU really is a big benefit for the cost. CPUs still can't process graphics nearly as well as GPUs, and what we're finding now with uncompressed IP, the memory bus is consumed with just dealing with the TCP I/O because there's so much encapsulation and de-encapsulation. So, and for compressed systems, the GPU helps us with compression because having multiple streams in and multiple streams out is very CPU intensive, and it can be better done by the GPU and improve the quality of your streams. So why do we need to still do that? Because broadcasters still want their brand to look great. They want to keep their customers by doing graphics in program, in channel, and across channels, and they want to be able to have high quality graphics. I had a few samples of the graphics that can be done in computer-based servers, channel in a box, some people like to call them. Each of these is graphics that we do in our own systems. 2 picture boxes, 2 video boxes, dynamic text on coming up next billboards, the tickers, the L bars, the video in the side with data sources coming from servers or from RSS feeds. All of that stuff is dynamically generated inside the box. And a few other examples, a little more detail. This is the software we use to create those graphics. It creates timelines for each of the events, so each part of that graphic can be built on a separate timeline from the rest of the graphic. This particular layout has all of the features of the L bar in one graphic, but you could alternatively create different panels of that graphic with different graphics templates and have those operate independently, so you can bring them in and out at independent times. I've got some live video graphics that I can show you as well. So here we've got dual DV squeeze with live video and graphic text around it. And we'll swap the audio in mid-transition. Here we've got automated ratings bugs, looping logos, and a countdown timer with video playing from the asset that the timer is referring to. Here we've got a lower third. The data always comes from RSS feeds, so you create this lower third once and you simply feed it data to keep it current. All this weather information actually comes in textually. The graphics are substituted based on the template replacement for the text incoming. Countdown timers that are actually based on the schedule that's in your playlist. So these coming up next events read metadata from the playlist so that if you have changed the schedule just a moment before, the graphic is completely up to date. And we talked about the L-bar with the ticker, and of course, I forgot to mention the DVE squeeze that goes on behind the L-bar. So a lot of stations are doing hot starts so they can get a little more advertising time. They can start one program while the credit is going out on the other program, and that gives them another 30 seconds of advertising time during the half hour. And this is advertising during the programming. And during certain programs, advertisers are willing to pay extra just to have a small part of the screen that's actually during the program. So the functional requirements aren't changing. Just because we're talking about going to the cloud doesn't change what people want to do. In fact, the functional requirements are getting more complicated. So we can't ask our producers to do anything less than they have been doing. What is changing is how we scale out. In the old scale out model, you used to buy a set of servers and you'd install them and you'd get them working. And then if your boss said, we want to do 2 more channels, you'd have to start buying hardware, working up new diagrams, installing all that new kit, getting it working. In the new model, you open up your virtual machine management platform, whether that's VMware or Amazon Web Services. You click an icon, you buy an instance, and you give it a configuration. So now you can build with little lead time. And if you have the advanced hardware in place in your VMware farm, you can bring that channel online within a matter of days. When we talk about the cloud, there's a little more to it than what I said at the beginning. Some people talk about the private cloud, and all that really means is you've built your own data center with your own generic compute. And some of the compute is available in reserve. So you still own everything, you still manage everything, it's still in your space. You also pay for everything. And you pay the overhead of the parts of the hardware that you're not using. It's a good way to start. You can build your data centers to be redundant so that you can go with operations following the sun. You can have redundancy within that data center because it's all software configured. It's also a good way to start because you can integrate that with what you're doing in the public cloud. I'll get into that a little bit later. Some of your virtualization platform choices are VMware, OpenStack, and KVM. We're a little partial to VMware, mostly because it's worked best for our virtualization. So right now, that's what we're working with. But the others do work, and some of them that are allegedly free still also have costs. One of the things with open source software is that support isn't always directly available from somebody who's responsive to you. You might be working through blogs and support groups. And the other thing with virtualization in your own premises is if you're really a broadcast house and your engineers are essentially broadcast engineers, the skill set of dealing with virtualization systems is completely new. And those people that you have may struggle with it. You may need different resources to be involved in your broadcast operations. You may already have them in your IT departments, but it's a different skill set to deal with virtual machine management than it is to deal with broadcast equipment. There's other hurdles. Typically, in the IP software-defined video networking world, video streams are transmitted in multicast, which means that they go everywhere unless managed. Now, that's not a problem, that's a benefit. And the problem with that is that when you build your own virtualization platform, you've got limited I/O on each of your racks of equipment. And if you don't have the bandwidth to deal with the full stack that's arriving at your host, you're going to have networking problems. It's not unresolvable, but it is something that you have to consider that you never had to consider with a video spigot. The video spigot was 1.5 megabits per second all day long. And in fact, IP really wants to be 1.5 megabits per second all day long too, so it doesn't have time to deal with network clogs. We use network translation in some instances to deal with that and limit the streams going through and change them to unicast instead of multicast. Other hurdles, as most people are aware, when one operating system has full control of the hard drives, they generally get better performance out of it. Same with GPUs. If they're not virtualized, they perform better, and the video audio interfaces on the device don't virtualize well either. We do have to live with IP/I/O in the virtualized world. So I spelled uncompressed wrong. One of the options is to actually go to compressed streams. SMPTE 2110 defines uncompressed I/O, and that really puts a load on the level 2 cache buffers handling the TCP encapsulation and decapsulation. So you need special buffering and smoothing on top of the normal OS functions. And as I said before, when a whole bunch of streams are trying to go through one port, if you've got more than one host accessing a 10G port, you could easily overwhelm that port, especially when you consider external key and fill and program and preset video all being active at one time. That's one host demanding 6 gigabits of data. So if you have two hosts sharing the same 10G I/O, you're oversaturated. So what a lot of people do, what we do, especially in public cloud, is go to compressed I/O. And that brings things down under 100 megabits per stream usually, and that gives you plenty of I/O, and for broadcasting, quite reasonable quality. The public cloud, on the other hand, is a completely virtualized and hosted environment. You've heard of software as a service or infrastructure as a service. Somebody's offering you the ability to go to their management software and say, I want this much network bandwidth, I want this much CPU power, this much RAM, and this much disk. And you just have access to it. They offer it as a service. You pay for it based on the volume you use and the transactions you use. A few examples of the public cloud providers are AWS, Microsoft's Azure, and Google. Public cloud offers us practically infinite compute power and bandwidth, and you don't have to invest in anything you're not using. Nice thing is you can grow it easily. Amazon, I know, has lots of reserve capacity. You can get access to it without reserving 3 months in advance, and it's usually immediately available. In addition, the public cloud offers worldwide access. You can replicate content from one region to the other, and there's storage capacity available for you without you having to create infrastructure in a part of the world that you may not be currently working in. CDN models allow you to distribute content so that it's easily accessed, immediately accessed, wherever people are working with your systems. There's a few items that concern people with the public cloud. Some are afraid of security. We've all heard of hacks, specifically with iCloud and Microsoft Mail. There's concerns about what happens when a data center goes offline, or if the network connection you have to the data center goes down. And broadcast engineers really like to be able to go into the rack, pull out the card and reseat it, worst case scenario, because then they're pretty confident it'll go back to the working state that it was. It's not quite like that in the public cloud. I have more information on that a little bit later. One of the other things that is a concern is what about the cost of your data, putting it into the cloud, and more importantly, getting it out. If you ever decide to change cloud providers, to get that data back out, there's an egress fee, and that's something to consider. That might be a rational reason to maintain at least storage in your own premises, so that next time if you change cloud providers, you're only delivering your files up, not paying for egress. What are the drivers for the public cloud? One of the first drivers for the public cloud is business, cost. People think, and the cloud marketers have done a really good job of saying you're going to save money, your company is going to save money if you move your IT to the cloud. It can also be true for your broadcast infrastructure. Your own hardware and data center investment costs you money. So does your maintenance cost, and so does the cost of having over-provisioned your own systems, because when you build your own data center, you always have to over-provision, even if you're not going to be using the system, some of the systems 90% of the time. The other thing that's coming on strong is content growth. We're seeing new kinds of content for VR, for 4K. All those files are getting bigger, and there's more of them. So we always have to be building more capacity. And again, building that in your own plant means you have to buy a chunk. There's a minimum chunk that's going to be your next expansion in the storage that you're buying. When you're storing in the cloud, the minimum chunk you buy is the size of the file that you push to the cloud. Competitive pressures. We all hear about cord cutting. We all hear about people using alternative services for watching their entertainment. So our bosses all want to save money so we can keep doing what we love to do, broadcasting and making money. So the one thing that they have to deal with is cost. And competitors are moving that way. And competitors from overseas. So you get to see worldwide providers of content accessing your customers, your viewers, over the internet. So we have to find ways to meet the demand to save money. A less clear cloud driver is dealing with peak demand. It's not something that we probably think about very much today until you acquire a new program and you have to ingest all 30 seasons in 1 month. And then you have to figure out how you're going to shift your resources to do this particular task. The cloud gives us the ability to grow for that peak demand without major pain. Mentioned a few cloud risks before, the chief being loss of control. And I think that really scares people the most, is that a certain amount of our control has now gone out of our hands. But as my director of development likes to say, you got to start treating that equipment like cattle, not pets. I don't like the analogy, but the thought is correct. Cattle, when we're done with them, we send them off to market. Pets, we tend to nurture well beyond their healthy life, and we spend a lot of money on it. It's the same way we treat our hardware in our racks, because we have to nurse an extra 2 years out of it to get that amortization that we promised the boss we'd get. In the cloud, you kill that instance. If something's gone wrong with the instance, you terminate it. You start a new one just like it. It didn't cost you anything, nobody lost anything, and you're back up in business. The other thing we do is we use some best practices to mitigate the feeling of loss of control. And I'll talk about those in more detail as well. There's a sense that the cloud is less secure. Now, I don't know about your IT department, but is your IT department 24/7 monitoring attacks on your systems? Is your IT department monitoring all the CERT advisories and updating the systems as soon as they hear about them every day? Is your IT department really on top of internet security? Are they the best of the best? And finally, is security your business or is broadcasting your business? At least cloud providers, their claim to fame is that they have teams of people dedicated strictly to hardware, to data security, and that is their business, so they have to be good at it. Another issue is cost. We said one of the drivers to the cloud is savings. But one of the things that people are concerned about is they don't know how much they're going to save when they go to the cloud. And it really is an accounting exercise. There is monthly fees, there is egress costs, but compare those costs to everything that it's costing you to maintain your hardware facilities today. That includes floor space, staff, power, air conditioning, hardware replacement, over-provisioning. All of that goes into assessing the cost of one versus the other. Don't get me wrong, Amazon's not in this to lose money. They're making money, or at least their business plan is to make money. So they're going to charge you more than it would cost you if you were working at the same scale as them. So some of the best practices we can use for data protection. The inherent data protection that you have in Amazon's cloud offering, I'm going to refer to Amazon because that's mostly what I'm familiar with. They keep 5 copies of every single file within one region. Your best practice is to replicate that content across multiple regions. So if you have your primary business in Amazon East, you have all your files there. Now, where are you going to put another copy of those files? On your premises, in an S3 storage vault at your place, or in one of Amazon's other data centers? Because we do know that Amazon had an outage here last year that lasted, 9 hours? You don't want your data to be gone for that long, and you certainly don't want to be not broadcasting for that long. The same applies to gaining uptime. First, you distribute your compute across availability zones within an Amazon region. Is anyone here familiar with availability zones, or am I throwing around terms that I should define? I'm going to go back and define that. So within one region, Amazon has multiple data centers. So they are actually physically different data centers that are linked with high-speed links within one region. They can be treated as one equipment rack room from a compute perspective, but they're in different buildings. So an outage that impacts one availability zone won't necessarily impact the other 2 to 4. They have up to 5 availability zones within one region. So by distributing your compute across those availability zones, you keep most of your systems up and running. And so you build clustered systems so that at most, hopefully, one node out of a cluster goes down. And most of us know that in a 3-node cluster, you're still fully active when you're down to 2 nodes. The other thing you do is you mirror the operation in another region. So if you have 30 channels playing in the US East, you deploy 30 channels to play in the US West or in Europe. Europe and the US aren't likely to have the same cataclysm at the same time. You can get access to the European region if you have any ground presence at all in Europe. To save, the last point in uptime is multiple links. So between your US region and your facility, you probably want to have 2 links from the cloud to your on-premises through 2 different co-location services. That way, if someone puts a backhoe through the fiber coming from one place, you still have the fiber coming from the other place. That's generally going to be just a great practice if you have anything to do with fiber links to your uplink facility anyway. You've probably been doing that already. And cost optimization is done by choosing the right virtual machine instances. Each instance has a value. It's based on its compute, its GPU resources, its disk space. You need to pick the one that is right for the processing that needs to be done by that compute. So they can be small and inexpensive. They can be large and quite expensive, well, relatively expensive. But picking the right instance for the right task. As a company, that's one of the services we do for our customer, is we recommend the instances for each of the types of functionality we do. You can also take advantage of serverless operations. Amazon has what they call Lambda functions. So who here uses FFmpeg to analyze a file from time to time? Okay, one at least. Amazon has a Lambda function called FFmpeg. You don't even have to start a computer. You can use a command line to call that Lambda function to look at a file that's stored, and it'll give you results. You don't have to start an instance. You pay fractions of pennies for what that function does. So you can do this as part of your actual practices. Amazon also offers computer on a spot market. It's like a Dutch auction. The lowest bidder, the highest bidder at the lowest price gets the compute. So you can bid however low you want, and if there's a resource that matches your requirements, you'll get access to that resource for whatever price you bid. You adjust your bid to make sure you retain those resources as long as you need them. But you can take advantage of the spot market to do tasks in the short term if you don't need a 24/7 operation of a particular node. Some advantages that we find in the cloud. As I said, they're in the business of maintaining infrastructure. They're going to be adding new computers. They're going to be removing defunct computers. They're going to be maintaining the security updates and patches. The latest Microsoft or Intel CPU bug that was the rage last month was patched on Amazon, I think the day that the public got aware of or the day before the public got aware of the bug. It happened for our customer before we knew it was happening. But because we managed the instances, that happened almost transparently to the customer, even through the instance restarts. There's new functionality available in the cloud. How many of you are experts in AI? Yeah, me either. There's lots of really bright people working for people like Google and Amazon and IBM, and they make great artificial intelligence stuff. Guess what? It's in the cloud. It's available to be used. So moving to the cloud gives you new things you can do. Facial recognition, object recognition, voice recognition, all those things. You've probably run an application on your computer that can do voice recognition and create text. Some of us like to do our typing that way. Is that in the budget, Dan? Anyway, the other thing I mentioned before, it was CDN services, so that your content can be replicated to all kinds of edge caches. So if you're delivering to video on demand services, you can cache right to the edge directly from your cloud instances. And regional replication. So if you have regional replication between here and, for example, Europe, you can, or Asia, you can have people working here 9 to 5. You can have people working 9 to 5 in Asia and 9 to 5 in Europe. And all that content is available to all of them so that they can be working on it not in their overtime hours. The other thing you can do easily in the cloud is disaster recovery. I mentioned before having actual active playout in 2 regions. Well, that's easiest done if you have automation in one region controlling both regions. But what if that region with the automation goes down? Well, 2 things, at least in our instance. The servers in the other region have cached the playlist, and they also have all the material on hand. The other thing is we normally architect a backup of the database in the other region. Using CloudFormation templates to build all the instances and the infrastructure, we can now spin up that region using a playbook to bring, if it's a long-term disaster, we can bring that region up to full capacity in a very short period of time, because nothing is unique. There's no special hardware. You can stand it up. You can also run both regions active. That's more complicated. Now you have to have automation systems talking to automation and replicating schedules. It's more complicated and more expensive. You can also build the second region and make the machines dormant. One of the features of Amazon is that if you create instances and then you spin them down and just save the configuration and the data, you pay, say, 1/10 of the cost of the running machine, because they can go out and put that machine on the spot market and make money on that machine you're not using, but you can spin it up at a moment's notice and it's fully configured. And hybrid operation. If you've elected to build your baseline operating cloud on premises, you can use the same technology in the cloud on demand if you need to. Our software for all of our products is exactly the same whether it's on bare metal, in a virtual machine in VMware, or in the Amazon cloud. So now you've got elastic capacity that you can take advantage of if you need to. Just a quick picture of where Amazon is in North America and in Europe. And this kind of a overlay of what I was describing of having 2 regions effectively mirroring facilities. And then you bring both regions down to 1 or more facilities on the ground. Moving just briefly to visualization and monitoring solutions. As I said, the third screen, the one on the right, is, in our case, usually a touch screen. Dan likes to call it an iPad for broadcast. This is one particular layout. This particular customer is a service provider. They've got 4 sources that they can switch between in addition to their file playout. That's all the controls they need in the system. Oh, and which server's on air. This is a different operation. They need a lot more control. Each one of the sections of the screen here is a widget. You can make it as big as you want, as small as you want. You can pack as much functionality in it as you want, given constraints of the real estate. This is a different control surface. This one is used to control multiple channels at once. In the right-hand pane, you select all the channels you want to operate. This is particularly useful if you have channels simulcasting a live event. You pick the ones that are on that event, you press take next, all those channels transition to that event in one operation. This is more of a single channel manual operation control system. It interacts with automation. You see the automation list in the top left. It gives you near field program and preset output and keyer control and transition control for live sources. When you get into compute-based broadcast, you need to have tools, an IP-based broadcast, you need to have tools to see what's going on in your system, because things may go wrong. Packets may drop. Things may start flooding a network port. You need to be able to analyze the whole path of your system, and that includes what's going on inside your video server. So this is one monitoring tool. This is another monitoring tool. This gives you metrics about what's going on inside servers, what's going on inside workflows. Using these metrics, we can start analyzing when you're reaching or about to exceed capacity. You can then plan in advance to increase your capacity before a problem happens. And we can set up these dashboards to alert us so that we don't have to be literally monitoring them all the time. I think in the heading, I said I was going to have a case study. So I was involved in the project that Discovery did to put all of their broadcasting into the cloud. Here's a fairly long quote from John Honeycutt. Really the important part is the red part. They decided to reimagine what infrastructure could look like by moving to a software and public cloud environment. The reason is they want to be agile. Tomorrow they want to start adding channels willy-nilly. They don't want to plan and build a whole business case around a channel. They want to try a channel. And then they want to be able to turn it off. In their lobby, while they were running in shadow operation, they had two screens side by side so that their employees could start feeling really good about the fact that things were going to work. It wasn't going to be the end of the world, that the hardware was not going to be in their facility. This is a live shot. Coincidentally, the pictures are on the same scene. The servers were running together, even though they were running completely different automation systems, completely different servers, in completely different locations. So I showed you an overlay earlier of a sample, Amazon's reference design for multi-region. Well, guess what? This is what Discovery's multi-region design looks like. They've got a one region in US East and one region in Europe West. For each region, they're connected to two different colos for their direct connect. Their pipes are 10G. They got a lot of files to move, and they got a lot of streams. They've got 30 different channels running in each location. And that's just the US broadcast operations. They're also building UK broadcast operations as we speak, which will involve another 120 or so channels in the very, very near term. The unique thing they've done is they've got both colos going to both London and the UK. London and the US, and they have their own backbone across the Atlantic. So their feed from Europe and their feed from the US both arrive in Sterling, Virginia, and from there they, well, I'll show you what they do there. The one thing I want to show you is they have a site called USDR. That site is provisioned with the equipment that they have in Sterling, so that in the event that Virginia gets taken off the map because they're in the flight path of Dulles Airport, and so and Amazon is within a certain radius of their location there. They want to be able to have a U.S. operation completely dependent on the European facilities. So they have a site somewhere in the U.S. that's ready to be hooked up to the links to Europe. So that's their kind of fifth layer of protection. This is what it looks like. I was describing availability zones before within the region, and you can see different channels are distributed across the availability zones in each region. They both come down to the colos in each country. Then they arrive as IP streams compressed to the premises in Sterling. From there we have to convert to video to feed their transmission facilities, to SDI video. Between the two feeds from Europe and the east coast of the US, there's a network latency difference. I don't know if you've ever tried to connect to a BBC website that's not co-located here in North America, but things slow down. Streams don't slow down, but it's because of the latency, which is more than a couple of hundred milliseconds, there's a delay in traffic. That means that if you did a switch between the two streams, you would get a perceived time shift in what you were watching. You'd go back in time or forward in time. So the clean switch system that we have realigns the time of the two streams so that when they switch between the Europe stream and the North America stream, there's no perceptible difference to the audience. And then after that, it's the standard stuff you guys are used to: distribution, encoding, stat muxing, satellite uplink. Like I said, Discovery is now on air, all their North American channels. That's 50% of their North America revenue, is all dependent on the cloud. Not only are they on air, they're on air 24/7, 365. Not only are they on air, but they've done actual real live events. Their first live event gave Dan a heart attack. Dan's a car buff. He knows what the Barrett-Jackson's auction is all about. In fact, he wanted to buy that car, but he didn't get a big enough bonus. So the key thing about the Barrett-Jackson auction, though, is it's 40 hours straight. So those effects we had to do, the DVE moves, the commercials during programming, that all had to be done in Discovery's very first live event. Guess what? Not a hitch. Went off perfectly. You guys have all seen a control room. I bet your control rooms look a little like this depending on the scale of the number of channels you have. You got your automation system in front of you. You got your multi-channel timeline. You got your big wall with all the pictures on it. Guess what? Discovery's control room looks exactly like that. This is a picture of it. The unique thing in here is that the two pictures that are pointed to with the arrows, or in fact the two rows of pictures, one picture is coming from North America and one picture is coming from Europe. And again, their operators operate just like they're at home, just like the equipment would be in their equipment room. Just close-ups of the automation playlists and the timeline. The timeline gives you the benefit of seeing multiple channels at once, and also can give you the option to do transitions on multiple channels at once. Just to go back and cover a few key elements on the road to efficient playout chains. Heavy integration. Move everything into one box. All the keying, audio processing, video processing. It's easier to maintain. We're going to have a bit of more discussion about asset management, but tight integration with asset management is key because that means less work to have your broadcast output. Simple and configurable control surfaces. I showed you the touchscreen surface, the iPad for broadcast. And virtualization. Virtualization can make things cheaper for you, gives you redundancy and geographic diversity. All of this is about reducing your operational expenses. I see my time is racing by. I'm about halfway through. I'll hurry up. This is a quick diagram of a public-private hybrid operation. On the left-hand side is on-premises hardware systems, or on-premises VMware systems, and on the right-hand side is a public cloud instance. Can you tell the difference? No, they're the same. So, that's broadcasting from the cloud. Now, we have to get content to the cloud. The content has to be broadcast ready. That's where I want to talk a little bit about asset management, because some of that asset management is also going to move to the cloud. And I know there's someone in the room who's probably more versed on asset management than I am, but asset management should really be workflow driven. You should set up workflow processes, and things should happen when they need to happen. And when things go wrong, there should be error correction for it, and it should move on to some other process that deals with things that went wrong. Just one example of a workflow. So acquire and validate is usually the first part of a broadcaster's asset management system. They're going to receive content. They're going to put it through some processes, usually some software processes, so that things can quickly be analyzed. Errors can be detected that are just strictly technical to prevent problems on air. You can even go to speech-to-text and language detection if you're a multi-language facility and you want to make sure that you're broadcasting the right language on the right track. The advantages with the cloud is that, if, like I said, if you get a truckload of hard drives and someone says, I need these programs ready to broadcast next week, you can grow your capacity right now. You can even add that capacity to operations you have on site. From that part of the workflow, you now start to get into preparation and approval workflows. So the first thing we do in approval workflows is we review the comments that came up through the automated processes of language detection and technical verification. You can make a pass-fail decision at this point. Next, you might have to go through compliance workflows. Darn, 2 typos. In this case, you may have to put in comments, or you may have to ask for edits to make the material compliant with the time of day you're using, time of day you intend to broadcast, or the channel you intend to broadcast on, or the region you intend to broadcast on. You can go through from start to end, and you can put all those comments in. Assuming all your technical and compliance stuff is good, the last thing before you broadcast is you need to divide the program into segments, if it's not already segmented for you. You need to be able to time it out so that you can fit in all the commercials you need to fit in, all the breaks you need to fit. And so you can fit in the credit squeezes and things like that to take advantage of hot starts. The cool thing about the processes that we use is you can do all of this stuff using your web browser. You can do that using the proxies that we have and anywhere in the world. Remember, I mentioned the CDN is going to distribute your files to any part of the world, so you can have operators working around the clock in their daytime doing this segmentation. Because these things are workflow driven, You can run analysis on it. You can see which processes are taking you time. Whose content comes in with the most compliance issues? Whose content has the most technical issues? Because it's all workflow driven, recorded in the database, you can do analysis to make your operations more successful. And again, just a quick flashback to the advantage in the cloud, the universal access. Metadata becomes a key factor in productivity. In each step of the process, you add metadata to the content. It might have come in with metadata. You keep that as well. You keep adding to the metadata, and that metadata becomes searchable. Different kinds of metadata, descriptive metadata. This is the subjective stuff that says, you know, what the episode is about, the synopsis, the who's in it, that kind of thing. There's structural metadata. You know, how long is it? What bit rate is it? That kind of metadata. What raster is it? What aspect is it? And administrative metadata, who owns the content? If you're a multi-channel operator, or even if you're hosting other people, or if you have your own distinct channels where people shouldn't be managing content for the other divisions of the company, you want to be able to segregate that. You use metadata, you use roles for people, and permissions to separate that content. The cool thing in this part of the workflow is now we're going to take advantage of some of the new functionality that you don't have at home. For example, facial recognition or object recognition or speech to text. Say the content didn't come in with captions. Run a speech to text on it. Give you your first draft of the captions. Now you may have saved yourself effort in the captioning process. Run facial recognition on it. See who's in it. For your VOD platform, you now have the actors if that metadata didn't come with it when it was delivered to you. Object recognition, that's kind of a fun one. When you start dealing with international content, you find there's something called forced narratives. Actually, that's a different recognition. The object recognition, let's say you are in a Pepsi-sponsored program, and Pepsi has asked you to replace Pepsi or Coke cans during the show with Pepsi cans. Now you can find the Coke can using artificial intelligence. Because your assets are in the cloud, you can now take advantage of multiple platforms' services. You can link IBM services to your AWS data storage, probably vice versa, I don't know. You can link Google's services to your Amazon content. And you can call upon those services to enhance your metadata. Here's an example. This is just facial recognition. It's Chandler Riggs, and it's been returned by the artificial intelligence that that's who it is, but it's now been linked to the IMDb database to pull biographical information about the actor into your database. That's famous faces recognition. What about less famous faces? We have some of our own staff on the booth here that we taught Amazon to recognize. So it came up here that J.J. Van Dyke and Jonathan Smith are indeed human people. Or another one. This is a broader output of a video clip. And as you can see, there's a grid of values that were recognized, and at the crosshairs you can see that there was a mascot recognized. This kind of gives you a heat map of where in the timeline different things were recognized. So now, if you want to find that mascot, you have timeline points in your metadata to find the mascot. Let's move on to maybe something a little more practical, especially taking first-run movies and bringing them to your TV screen. If you're a typical North American channel, before 9 o'clock, you can't really run some of the content that's there. You need to find nudity/profanity and deal with it. You can get those results from the images you send to Amazon as well. In this case, it came up with female in swimwear or underwear. Probably okay, but at least you know it was there, you checked it, and you're not going to be in trouble. Same with this, and again you can see a heat map diagram of that same thing. That's all metadata that's now been added to your pile of metadata in the asset management system. And again, now that metadata is searchable. So applying that to linear broadcast, as I said, the biggest thing there is going to really be compliance. The nice thing about this being a workflow is I can now send anything that needs compliance changes off to the edit suite. Wouldn't it be nice if the editor had all the metadata saying where he needs to make edits? And those edits can be as simple as blurs or mutes. They may be more complicated. But with the integration, the basic integration we have with Avid, we can send the time points of all of those events to the Avid editor, giving them keyframes along the timeline they can just go and fix. When they push it back, it becomes a new version of the content because, again, it's an asset management system. It can keep track of the versions. So you retained your after watershed and your pre-watershed version of the content. What about nonlinear delivery? That content could be perfectly fine for nonlinear without changing the compliance. But nonlinear has a whole bunch of other requirements. So we build another workflow. This is a workflow driven just for nonlinear. And somewhere in the middle is a block called published. That's a good state. That's when you think you're done. Oh, the platform decided you did something wrong in the technical metadata. So now you have to reconform that content. Or the platform thought the bit rate was too low. Now you have to resend that. This workflow builds in the ability for you to go back and take input from the platform and correct their actions and still stay in the workflow. One of the things that you do with video on-demand content is you add pre-roll promos, mid-roll promos, and some people actually attach post-roll promos. I don't know, any revenue on that? Does anyone stick around after the credits? All of that can also be automated by building templates that allow insertion of promos. Where are you going to insert them? Guess what? Remember you did that segmentation? Maybe you created a 3-part segmentation for VOD and a 5-part segmentation for linear broadcast. So use the 3-part segmentation values that you created a long time ago and forgot about. Use those to build your VOD package. And also, by the way, put your bugs on timed relative to your segmentation timing. And then there's that nasty metadata that VOD platforms want. And everybody wants it differently. Ever notice that the ratings are different on Netflix than iTunes? You need a translation table to sort that kind of stuff out. So build in the translation table so that now when you have a product that you need to deliver to multiple platforms, you can do that without doing a whole bunch of work. You create the order, the job gets done using the templates you've created for metadata, for structure. Start compiling. Oops, forgot to say, everyone wants it packaged differently. Someone wants a zip file. Someone wants, I don't know, this XML file that's their own version of Cable Labs. Oh yeah, everyone has their own version of Cable Labs. But once you get that sorted out for each platform, set the wheels in motion and get going. Just a quick user interface. This is the one that lets you tear down from the platform and send back for repackaging or updating metadata. Again, we don't build a MAM system just to deliver content. We also build a MAM system so you can keep track of what you're doing. You need dashboards so that you can find out where you need extra resources for delivery time. You need dashboards to be able to tell you what problems you're having. That's possible when you have asset management systems in place, and you don't have people just fulfilling orders on paper. Here's a short list of some of the platforms that we deliver to. That's 70 platforms. That list is 18 months old. Mediator Systems deliver about 10,000 programs a month, every month, over the past several years. And again, just to point back to cloud services, the cloud gives you the CDN services for distribution. So if you process in the cloud, you can distribute immediately from the cloud using their CDN services, and you have replication of content, so you can do the same work in other parts of the world should your primary place go down. We also do analytics. We track how fast processes run. That's to give us knowledge about when deliveries are going to be complete. This is a queue of things that are going to be delivered, and the system has identified that 3 of those aren't going to make the delivery deadline. In your on-premise facility, that would be a disaster. In a virtual machine facility, you just add another virtual machine, or in the cloud, you take another instance, and you get that done on time. If the instance dies, you bring up another instance, you replace it, you get your work done on time. This was kind of our old thinking on how to deal with delivering on time. There might be a better way. What about spinning up all the jobs right now on separate instances and getting all the job done the day the order was created, using a lot of resources for a very short time, as opposed to using a few resources over an extended period of time. In the end, if you're only paying for the resource utilization, the math is the same. But you have the confidence of knowing that you've completed your work days in advance. You don't have to stress out about getting extra capacity or an error happening that causes you to have to redo that work for some reason. Just a graph showing using data centers, cloud data centers, to deal with peak operations. And again, the rapid growth and hybrid operation. So that's the usual asset management needs of broadcasters, people delivering to VOD systems. I'm going to go very briefly into asset management needed for content creation. Content creation is kind of a different world. I don't know who's in that world, but I do know there's somebody in the room who probably knows more about it than I do. She said she'd be nice. So the thing with content creation is it's a weird workflow. People collect things on their own hard drives. They keep those drives in their pocket. They walk away from the job with them. They come back with them. They put them in rooms. And when they're done, they put them in rooms, and they never leave that room. Well, it should be about here on the slides now. The other alternative is they put them on a tape library that's cataloged by a person. That way they can find the files if they need to, as long as the person who knows where they are knows how to find them. We've been asked by our customers to start using the workflow manager that we have, the asset manager we have, to integrate more tightly with the edit systems. That's meant we needed to add a few more metadata options to what we're doing with the content. Normally we did brand, series, episode, that kind of traditional broadcast stuff. Now people want bins. They just want to randomly throw assorted content into a list, or they want them associated with a campaign, so that when they're ready to work with that content, they can just request that bin be moved to their workspace, or they can search through the contents of a campaign to request an asset that they didn't have in their bin to move that to their workspace. So now when you're ingesting all the raw footage, you catalog it accordingly to those categories. That's meant we've built a more advanced, or building a more advanced Avid integration. And that Avid integration brings all those clips and selects into the Avid environment to allow editors to work on projects in the way they're used to working, but slightly more organized. What are the future possibilities for the cloud? Who's heard of data lakes? It's another new buzzword. A data lake is really simply a lake where you dump your data. You dump it exactly the way you got it. If you got a Word document, you throw it in that lake. Typically in Amazon, this is an S3 place, a bucket. It's really good if you put it into a catalog when you're throwing it into the lake, but it doesn't really matter, because what you're going to do with this data lake is anytime you have a new use for what might be in the data lake, you run processes against that data lake. You get new metadata, you get new results from what's in that lake. This is something you can only really do in the cloud. Cloud editing. Who's thought about moving their Avid suites into virtual space and having operators work from home, whether that home is London, Singapore, New York, being able to do their edits from the cloud. This isn't stuff we do. This is just possibilities for the cloud. And finally, Discovery is still bringing everything down to Sterling, just so they can put it back up through the cloud, as Chuck says, to the sky. Why? Distribute from the cloud. Have the telcos, the MSOs, pick up your signal right from the cloud. Save a step. Again, possibilities. This isn't even within our realm of something we would be coordinating, as far as I know. This is just things that the future holds for us moving to the cloud. So I got through that last half really well. I'm done. You probably have a bunch of questions. You're still awake? That's good.
You were charged with taking Discovery Channel and virtualizing it. How long of a process, how long of a project, and how many people were involved in the planning before the implementation?
Okay, I'm going to say a lot of people, a long time, and a very hard process. But I'm going to say the second thing. We learned a lot. We learned an awful lot. And I would say that the next project, we could actually forecast a reasonable time to do.
Was that like a first?
Discovery was our first. And it was excruciating. I didn't tell this, but I mean, we learned more about Amazon's network than they told us as soon as we started to get live streams in and out. There's problems, not insurmountable, but things you have to learn from and build technology to overcome, to be able to get streams in and out of the cloud in real time, frame after frame after frame.
Did the requirements, just a follow-up, did the requirements kind of evolve from the start of the project to the end?
They did, yeah, because by the time we were implementing, they wanted to do things that we hadn't planned for. For example, and this is one of the things they're still hybrid on, their social media feeds are done in some CG environment. I don't know what it is, but it has to be keyed in real time. So we have to go through some on-site hardware that's managed by the mediator system just to do that keying. But it's taking a compressed stream in and a compressed stream out, and it's a keyer in the middle. So we had to do some. Dan, what were you going to say about the learning process?
What are the time that it takes to do any of these enterprise class deployments, whether they be for media asset management or for Playout, that was corporate change that goes along with the technology document. It's not just about the document technology, but you're doing today and in this spot. How do we actually do things better when we actually go and do things? How do we change the workflows, change the job, and more efficient? We see this time and time again when we comes together with broadcast, and how it's going to change the editor's workflow, and it's going to change their lives, and maybe there's unions involved, and stuff like that. The time to deploy things that are enterprise stuff, this is about the technology anymore. It's more about what you want to do with the business, how you want to change it to become more efficient. That's honestly what I find every project we use, it's about that. Not the technology adoption. What do you want to do with the organization mind wrapped around that and going together?
So introductions, Dan Turo is my VP for file-based systems. Yeah.
You were mentioning the data lake.
Yes.
It's interesting. So whatever file I put in there, once I pick the correct name to pull it out, it doesn't matter. It doesn't say it must be a certain type of file. See that's
That's correct. I'm going to change the term server, though, because S3 is a conglomeration of servers. It's important because you can't do that on a server because the things you have to do to go back into the data lake and reassess everything that's there can't be done if everything's on one server.
so it doesn't matter what the file is, as long as it's a recognizable file.
Yep.
That's good.
Yep. And the reason for the cataloging, at least according to Amazon, is so that when you do a process, you can restrict that process to a catalog, say, of Word documents or a catalog of audio files. It's a really cool place to dump all your logs. So system logs and event logs and error logs from all your servers should go into that data lake. And then they should be analyzed. And we have a tool that creates a small data lake that we use for the analysis of our systems. I showed it briefly. It was giving you all the reports about the systems and workflow. It's called Insight.
The whole concept of some of the things we see in the data lake is really keeping, in the past you had a very structured metadata schema that everybody worked against and everybody aligned on and agreed upon and stuff like that. It was fairly rigid in terms of what it actually was stored there. As you go to the cloud, you can use dynamic compute to parse through a lot of things. Let's throw everything in there. Let's keep it and actually run things that you want to do in terms of post-process. To actually extract the data. You know you want to extract the data, but you may in the future. Right? And just as an example, we did the SMPTE, the nudity detection type thing. We talked about it, but every single frame comes back from AWS recognition with a confidence factor and different types of things that are actually detected. You can go back and go, I want to change my threshold at like a 70%. And then that's okay. Change your threshold again and run it through at 80%. All that data is there and completely searchable again. Unstructured metadata that allows you to run queries on a subsequent basis. Then you have dynamic compute, which will run through as quickly as you want. So give you the conditions of degree of freedom as opposed to a very structured metadata set that's fixed compute running through queries in a defined time.
So when you identify something, if we put up the title of it, like answer it, you can put in a word that concentrate on a sentence or something, and say you click on it, and then you're applying it, what was a statement. That makes sense.
Another use for it is traditionally broadcasters have kept their mezzanine format, and if something came in at 4K or SD and they upconverted it, they kind of threw away the original. What if there's a better technology for upconverting that SD now and you want to broadcast a better version? If you kept the original, you can reprocess that. You can reprocess all of your SD content if you keep the originals. Or by keeping the 4K, now you can make a new version at a different resolution than you previously wanted.
One question, is it in there in original resolution or you compress it?
However the file came to you is how you keep it.
So that's the original. It doesn't have to go compress it, keep it in there,
Right.
and then reconstruct it come out.
Other questions? Yeah.
You showed in the case study that discovery was, when they're coming back to Sterling, going IP to SDI
Yeah.
version. Are you finding that to be the norm, or are clients trying to stay IP throughout the whole can discern?
That's going to be client dependent, right? It depends what they have to deliver to where. There's very few, well, I guess you can use transcoders that take IP in instead of using encoders that take SDI in, but they weren't ready to replace that part of their infrastructure today. So it's every client has their own reasons for doing their own things.
In their particular case, it's more of a, they just put in the encoding platform, it happened to be SDI, and it's kind of like, I'm not really ready to script that in, and I don't want to turn on that quite yet. So it was just pure financial. When you take IBM, absolutely to IBM, IBM transfer from resident to mission level coding.
Yeah?
Basic question. I think I have a good understanding of public cloud, but I'm not sure if there's a difference between virtualization and private cloud.
Private cloud is just the name for virtualization. People have been trained to say the word cloud.
Okay.
I have a virtualized environment in my plant. I can call it a cloud, I guess.
Yeah, virtualization is just the abstraction of the service that you want to actually run in the hardware platform it actually sits on. So it could be you have a farm running generic x86 compute on-prem, or generic x86 compute in the cloud, or it can be heavily developed. Hardware accelerated FPGA stuff that could run all kinds of different things. Just virtualizing the service and the function away from the actual hardware platform.
Other questions? Yes?
I was just curious that you have the Neater integration with Avid NLE. Do you have integration for other NLEs, or is that coming?
We have integrated with Final Cut Pro again at a basic level. We're looking at the particular customer doing the integration for the first location that we're doing runs Avid. The next location runs some kind of Mac editor. Yet to be, could be Premiere just as well as Final Cut 7. Other questions?
When you're integrating with Avid, are you doing that as in a plugin, so you're within Avid, but yet you're running within Avid?
Interesting. I didn't show any of the stuff, but the user interface is moving to HTML5. So really, one of the possibilities, not a plugin, is just a pane in the Avid interface that actually runs the exact same GUI as here. For rendering out, it's a different function. Can be done as a plugin. Yep.
I was wondering, and you kind of had the three sections, so the first one in the cloud and all of that of discovery is doing that. In the middle section, some of the fun stuff with AI and those heat maps, is that stuff that's already deployed, or is kind of...
That's kind of stuff we're interesting to look at. Things you can only do in the cloud. And
Is that an Amazon function, or is that something that you guys are doing?
the metadata identification, the analysis, the artificial intelligence is completely Amazon. We send a movie file to Amazon. It gives us back everything it knows based on the function that we called in Amazon. So that's a pure Amazon function. Us parsing the data, laying it out as a heat map, for example, that's us. We're just reading the data that came back to us and formulating it. And we don't know what the real application for that is yet. It's just something that the cloud brings to the table. Any other questions? Well, thank you.